Welcome back, fam. This is Mr. James, the decomposing the synthesizer of Math and Science Tutor. Today, guys, I want to cover on something on number patterns, right? So I just want you guys to check on this, right? This is just a small basics for you guys to get know, man. So if we have a pattern called an arithmetic pattern, how does it look like, you know? And what do we do when we are basically dealing with an arithmetic pattern? So I want you guys to know that a pattern is more like a pattern and a sequence is basically one thing. So if I want to say number arithmetic pattern, I can say arithmetic sequence, or I can also say linear sequence. So sometimes a linear sequence is called an arithmetic sequence, right? So this sequence is a sequence in which the first difference has a common difference. I don't know if it makes sense. Like if I have, let's just say I have 3, 5, 7, then we need to look for the next two terms, right? So if I get the first difference from this sequence and it happens that the value that I get is the same, then we call it what? Common difference. So the first difference you get and it becomes common, it becomes constant, it remains the same, it doesn't change. That type of a sequence is called a linear sequence or an arithmetic pattern. Okay? So that's the one there. The formula is given as Tn, which is the general term. So in case the examiner or in a test they ask you to determine the general term, some people use the word nth term. If they say determine or calculate or find the nth term or general term, you must know that I must look forward for the formula that can generate the sequence. To generate the sequence is to make sure that we have, to keep it going, yeah. So if they ask you to determine the value of position 5, you know how to, you can use the formula. If they give you the position, they want you to determine the value of that position, you use the formula. So that is the importance of the nth term or general term. Okay, what is the formula? The formula is given as a plus into n minus 1 times d. A is known as the first difference. We call this guy the first term. The first term of the sequence. I'm going to show you how to do it. And then this guy is called, or he's known as the common difference. Common difference. He's the common difference. And then the n stands for the number of terms. The number of terms in the sequence. The number of terms in the sequence. And then this Tn here alone is basically the value. We can call this guy the value of the term. Value of the term. He's the value of the term. So I'm just gonna show you how to do this guy, right? Okay. So let's just work it out fast. So the first question will say determine the next two terms. Determine what? The next two terms in a sequence. And it says 2 marks. That's first question. Oh, sorry. The first question, 2 marks for 1, 2, right? So we need to firstly determine if it's a linear or any other pattern, because there is also a geometric pattern or a geometric sequence, which I'm going to show you also. There's also a quadratic pattern or a quadratic sequence. This one is for those that are doing grade 11, basically. Those are in grade 11, they can do that. And then there's the one where you just, like the one with cubes, you just to multiply the power, it's basically the power 3, a cubed pattern or a cubed sequence, a squared sequence, a squared pattern is also there, which I'm going to show you as well. But for now, I want to focus on the linear and the geometric mainly. So check. I want to get the next two terms. We know this one is an arithmetic. The formula is given as d equals to term 2 minus term 1, which must be equal to term 3 minus term 2. My people, look at this. this guy, he is known as term 1. He's known as term 2. He's known as term 3. Okay? Term 1, term 2, term 3. So if they ask you, what is the value of term 1? 3 is the value of term 1. What is the value of term number 2? On term number 2, we have our value is 5. On term number 3, meaning our n, when n equals to 3, our value of term number 3 is 7. But whenever n equals to 4, which is this guy here, this is term number 4 and term number 5. We need to find the values of term number 4 and term number 5. Okay? So we don't know that guy. Okay? Awesome. So this is what you're going to do. You say term number 2 minus term number 1, it must be the same as term number 3 minus term number 2. So look. 7 minus 5, 2. 5 minus 3, 2. Remember, term number 3 was minus term number 2. I got 2. Term 2 minus term 1, I got 2. Do you see that already we are having a number that is not changing, it's just the same. So whenever the number is the same, we say it's a common difference or is a constant difference because that number doesn't change. Okay, so look at this. Basically, for us to can find the common difference, we need to take common difference. We need to subtract because difference in math is all about minusing, right? Minusing terms, we are basically going backwards to can find that guy. So since we want to generate the sequence, we're gonna say 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2, so it means everywhere there is 2 now. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So this is how we can get the next two terms without having to use the formula, guys. Alright. So now on the second question, they're gonna ask us to determine the nth term or the general term of the sequence, right? Can we do that? Yes. Okay. So remember d equals to term 2 is 5 minus term 1 3, term 3 is 7 minus term 2 is 5. We know 5 minus 3, this is 2, even this is 2. So you can see the common difference is 2. And then what is a? We said a is the first term of the sequence. What is the first term? 3. So my a is 3. So the formula says Tn equals to a plus into n minus 1 multiplied by the d. Okay, so I'm going to substitute everyone that I have here on my formula. Okay, so where I see a, I'm going to put 3. So I'm going to have 3 plus into where I see n, I don't do anything. N minus 1, I have d, yes, is 2 times 2. Some people will be like, what are we going to do here? Okay, we're going to use the following method, right? You're going to say 2 times this guy and 2 times this guy, right? Which I believe I still have 3. 2 times n is going to give us 2n. They are all positive, by the way. Positive times positive is positive. Hence, we have positive 2n. Positive times negative, I have negative. And 1 times 2 is 2. So I need to now check what we call the like terms. Like terms are basically the numbers of the variables that are the same, right? And if I can check here, I can see this guy, he doesn't look the same with anyone, but these two, they are all numbers without letters, so they are basically like terms, they are bodies, right? So when I'm going to end up having 3 minus 2 is 1, so I'm going to have 1 plus 2n. This is my formula. Someone can also write it like this. So that is basically the nth term or the general formula of this linear sequence or arithmetic sequence given to us, right? I hope it was clear, eh? Awesome. So this one was basically like 3 marks, 2 marks, already have like 5 marks, you know. So there's another one that can show up, which could also be 2 marks. They will say to you, determine, meaning this is the third question. Determine the 15th term. Determine the 15th term. So in other words, we are given the n equals to 15. When they say determine the 15th term, it means we are given that the n equals to 15. What are we looking for? We are looking for the value of term number 15. Do we have, how can we get it? Our formula is right there, guys. So I'm going to say, term where I see n, I put the small 15 equals to 1 plus, I can use this guy, or you can use any, plus 2, where I see n, I must put what? 15 into 15. And then 2 times 15 is basically 30, right? And then it means our answer is going to be 31. So on the position 15 or term number 15, we are going to have what? We are going to have this guy here. Okay, awesome. So even if they would say determine the 10th term or the 100th, or maybe they can say the 50th term. If they say the 50th term, this is what you do. You say term number 50, where you see this n, you put 50, and then you say, I can use this formula now. This is the same thing, right? So I'm going to say 2 into 50 plus 1, and then 2 times 50 is going to give us 100 plus 1, and that's going to be 101. So meaning on term number 50 or on position 50 of the sequence of the pattern, we're going to have what? 101. Guys, that was easy. Lemon. This is what people like to say. It was what? Easy peasy lemon? Squeezy. You got it, my guy. So yeah, that's how you actually determine this type. This is basically how you can calculate or find the answers for all these questions regarding linear sequence or arithmetic sequence, right? Yeah, this is the last one. Here's the last one I need to say. Here's the last one. You see, the question will be to you, number 4. They will say to you, which term in the sequence equal 101? They will say which term in the sequence equal 101? You see, this type of questions, people, they just tend to lose marks here, alright? So guys, I want to be clear with you. Every time when this guy comes up or shows up, right, you gotta know that this guy, he's basically the value of the term. This guy is always what? The value of the term. The what? The value of the term. The what? The value of the term. The what? The value of the term. Do we have the position of the term? No. That's why they're saying which term. It means we're looking for who? And we don't know him, but we know that the equals to 101. We know that this term equals to this guy, but we don't know which term is there. That's why they say which term in the sequence equals 101. Equals, by the way, equals that guy. So for us to can find the term or the position of the term, we are going to take this guy, right, and put him where he belongs on the formula. So this is our formula. We're going to say 101 equals to 1 plus t, and then here you can see, right? From there, you're going to solve, right? So for us to can solve, we need to put the like terms of the people or the bodies that are basically the same, right? If you can check, this guy is just 1 and does not have a letter. This guy also does not have a letter. So what I'm going to do, I'm going to take this guy, he's going to go. This is what I'm going to tell you guys. Every time a number or a letter crosses the equal sign, he or she, they get married. If I'm positive, as soon as I crosses the equal sign, I become what? Negative. If I'm negative, I tend to cross the equal sign, I become what? Positive. So this guy is going to become 101 minus 1 equals to 2n. Get it? Then from there, I'm going to get 100 equals to 2n. Guys, I'm looking for who? N, not 2n. What do we do? The law of mathematics tells us that whatever that you do on the left, you must also do on the right. So I'm going to divide both sides by 2. So I'm going to say 100 divided by 2. divide by 2. See, what you do on the left, do on the right. Okay, and then from there, how many times does 2 goes into 100? 50 times. So meaning our n equals to 50. So we're going to say, therefore, 101, it is the value of term number 50. That is how you answer this type of questions, guys, in case it shows up, right? Anyhow, like you guys can do this. I believe in you. Okay, so let's quickly go to geometry, because my goal is just to show you how to use these formulas and stuff, right? Yes. And for those that don't know, there is one of the videos that I've made on TikTok and also like on YouTube, but as a short on YouTube, right? It was just a song of linear and geometric, by the way. So, Bamija linear sequence, Bamija linear sequence, unali common difference, unali common difference. The formula is just the Tn equals to A plus into n minus 1 times D. That is the formula. And then geometric sequence, one major geometric sequence, geometric sequence, one major geometric sequence, geometric sequence, only common ratio, common ratio, only common ratio, formula Tn equals to A times N. Okay, here's the formula. Tn equals to A into R to the power n minus 1. Yes, this is the formula. Tn equals to A into R to the power n minus 1. That's the formula of your geometric sequence, right? So I'm basically introducing this guy now. Okay, check it out. Geometric sequence. Okay, this guy is our first term of the sequence. First term. This guy is known as the common ratio. Someone can say he's a constant ratio. And then our n is always known as the number of terms in the sequence. The number of terms in the sequence, right? And then this guy is just the value of the term. The whole thing is our nth term or the general term of the sequence, right? Okay, now let me just try to show you how can we work on this guy. Okay, so imagine we are looking for this R. R we said is the common ratio or the constant ratio, right? So with linear, the goal is to add and subtract, right? But with this guy, we either multiply or divide. You get it? So the formula is given as term 2 divided by term 1 equals to term 3 divided by term 2. If you're looking for the common ratio or the constant ratio, which is this R, you need to divide the second term. You see that term? You see, you can continue to say term 4 over term 3, term 5 over term 4, term 6 over term 5. Yeah? Just like that, you get it? That's your math, man. Okay. Which can you do? Okay, let's just say we can have 2. We can say 2, 4, 6, 8. No, not this one. I wanna think of something fast. Just give me a sec, okay? Let me just create it fast. I wanna create something. Or maybe I should use 3. I should use 3. Come on, James, you can do this. 3 and use 6. Come on, use 9. Or maybe I should use 112. Let me see, let me just do something. Okay, yeah, I'll just do this one. Then we do this, yeah. So imagine you have this kind of a sequence. It's 3, 6, 12, right? So you will never know whether it's a geometric or it's a linear. So if you want to know something is not a linear, this is what you do. You're just gonna do this, right? We know that with linear we must subtract or add, right? Since we're going back, we're gonna say 12 minus 6, 6 minus 3. You can see I'm gonna get 6 here. I'm gonna get how much? 3 here. Are they the same? The difference is not the same, guys. The difference is not the same. Do we have a common ratio, a common difference here? No. So what do? We think of Mr. Ratio. It means we need to try to divide. Let's see if we can be able to divide. Let's see if guys we can be able to divide. So check what's gonna happen. I'm gonna say
she's been calling me for like 20 minutes.
Then from there, check what's going to happen, guys. So I'm basically going to have R equals to, since our formula says term 2 divided by term 1 and equals to term 3 divided by term 2. So I'm going to say 12, term 2 is 6. So 6 divided by 3 equals to 12 divided by 6. Okay? So check it out. 6 divided by 3 is how much? It's going to give me 2. Because 3 goes into here twice, this guy goes in here also twice. So you see that after dividing, I'm getting the same answer. So that's what we call common ratio. Common ratio or constant ratio, we are basically getting it after dividing the terms. Okay? Awesome, guys. Remember, this is my term 1, term 2, and term 3. So that's basically what we do, guys, there, right? Cheers. Right. Then from there, you need to know how to find the formula or the nth term or the general formula of the sequence. Since we have the R, do we know the A? Yes, our A equals to 3. You see, A is the first term of the sequence, which is 3. So I'm going to say Tn equals to A into R to the power n minus 1. Tn equals to, who's my A? 3. Who's my R? 2. To the power n minus 1. You are done getting the nth term or the general sequence of the formula. How simple. Then now they can say to you, determine the next 2 terms of the sequence. Determine the next 2 terms of the sequence. Okay, we know that the constant or the common ratio is 2, right? And with geometric sequence, we either multiply or divide. So since I'm going forward, what do I do? Do I multiply or do I divide? I multiply. When I go backwards, I divide. Okay, so 3 times 2, 6. 6 times 2, 12. I still have 2. Everywhere means I'm having 2 because I'm dealing with the common ratio, constant ratio, because I'm dealing with geometric pattern or geometric sequence. So, yeah. So 3 times 2, 6. 6 times 2, 12. 12 times 2, 24. You see, what is 24 times 2?
24 times 2 is 48.
You're a genius, my friend. It's 48. You see, guys, this is how we get the next 2 terms of the sequence. Even if they can ask you the similar questions that I asked you regarding a linear or a geometric sequence, you can do that. But let me just quickly show you something. Hey, but it's fine. Alright, our formula is still here. I want to write, okay, check it out. So I'm having that 3, 6, that 12, and then here I'm having the 24 and 48. Okay, they can say to us, determine the 50th term of the sequence. Hello? Now you're gonna say Tn equals to 3 into what? 2 to the power n minus 1, and then T50, 3 into 2 to the power 50 minus 1. My people, my friends, then from there, just press put this person on your calculator and you say 3 into the power 2, 3 into 2 to the power 50 minus 1, aha, you're gonna get a very, very big number, right? Like this. So you can just convert this guy into 2 decimal places, yeah? Like 1,6, 9 times 10 to the power 50. Aha, leave your answer like that. It means the value of the 50th term in the sequence is going to be that. If you wanted to know maybe the 20th, or maybe the 10th, the 15th, the value, if they ask you to determine the 15th term of the sequence, so it just keeps on increasing. The further you put, the further that's how you generate a sequence. Yeah. Okay. Then let's just do it like this, guys. Let's just say we're looking for the value of the 10th term. Ne? I want to do something. Let me just do something. Okay, 1536. Yeah. Let me show you guys something. 1536. Okay, so the question says which term in the sequence equals to 1536? 1536. Which term in the sequence equals to what? 1536. So remember, we're looking for the what? Which term? They're looking for the term. We're looking for the n. It means this guy is the value of that term that you're looking for, right? So what do? When you see the Tn of the formula, you put Mr. 1536 and then you're going to solve for your n. That's an exponential part of solving things. Now, guys, check it out. I'm going to say Tn equals to 3 into 2 to the power n minus 1. 1536 equals to 3 into 2 to the power n minus 1. Guys, I'm looking for who? I'm looking for the n. What do? Guys, just divide both sides by 3, right? Remember the law of math says whatever that you do on the left must also do on the right. So I'm going to divide and say 3 into 2 to the power n minus 1 divided by 3. 1536 divided by 3. Let's see, 15 divided by 3. 1536 divided by 3. I get 512. 512 equals to 2 to the power n minus 1. So now we need to check if this guy, we can convert him into an exponential form, right? So 1522. I show you guys. This guy, on your calculator, guys, 1512. I get what I want to get what equals to. You see that, ne? From there, what is shifty, what effect. We are changing that bigger number into an exponential number. Then you can be able to solve, guys. Then from there, I'm going to have 2 to the power 9 equals to 2 to the power 2n minus 1. Guys, from here, if the bases are the same, we equate the exponent. So 2 and 2 goes, I'm left with 9 equals to n minus 1. Therefore, if I take this guy to the other side, I'm going to be having n equals to 10. So it means the 10th term of the sequence equals to 1536. Guys, this is how we deal with geometric sequence and number patterns. We're together, guys. Please don't forget to subscribe, to like, to share, and to comment. Love you.